the reference for a declination is true north. Can you see how I write that? North sub true. And your textbook doesn't call it true north. Instead, they call it astronomic. So you could call it whichever you want, but I'm just going to call it true because it's perfect. So the reference is true north. The direction is either to the east or to the west. And the value is whatever that number, whatever that angle happens to be. Brian.
I know we're going to talk about it later in class, but when they do lessons for surveyors, I've read that they still have to have a command of astronomic calculations and whatnot. Is that still the case?
I wouldn't know,
Okay.
but we could look it up. Because remember I put the whole review manual and the whole review video series down in the library?
Yes.
I probably would, rather than going down there, I probably would just do a search on the LSIT and the LS. Those are the two exams to see if it's on there. But I would be detailed in looking it up because if I use the term astronomic, they might think I'm meaning this bearing stuff, which you're going to know.
Okay.
But as far as calculating, I don't know it.
Thanks, John.
Yeah. Okay, so let's point again. True. I'm going to just put it up so everybody can see it because right now, if I put it like this, you can't see it through my body. So here's north, and let's say we have a declination of 10 degrees to the east. So notice that the declination not only has an angle number, but it also tells me whether it's east or west, right? If we look at that, the reference for the declination is always true north, and then I need to give you the number and tell you which way. So now, again, if we have a declination of 3 degrees to the west, my magnetic north is 3 degrees to the west. So if I want to draw it up here now, if I am saying that this notice is always my true, so I'm going to use blue to denote my axes for true. Here's my north sub t, south sub t, east sub t, west sub t. You'll notice in the packet I gave you 4 or 5 of these sheets. Okay? So this represents true north. If the declination is equal to 5 degrees to the east, I'm exaggerating. This is my magnetic north, and this is 5 degrees, and then when I transfer this down, here's my south magnetic, here's my east magnetic, here's my west magnetic, and the degrees here is all 5 degrees. This stuff kind of builds upon, it's detailed and it builds upon each other, so if you have a question, make sure that you ask the question before I move on, okay? And even though I'm not using a protractor, actually I should, because remember I brought
That huge
up
one.
those big ones, and I should be using it, because if you don't use a protractor, you could actually mess up royally, because it can pass over from one. So from now on, I'm going to use the protractor. So let's say we have this line here, a property line, AB, and it's 30 degrees here. So I have line AB, and I want to know what the true bearing is, and I want to know what the magnetic bearing is. So looking at where our line AB is and knowing that it's 30 degrees off the magnetic north, which is 5 degrees off the true north, write down what the bearing is of that line, both true bearing and its magnetic bearing.
From A to B.
Yeah, the line in question, the property line we're looking at is AB.
Got it.
Okay, Cody C, what's the, true bearing?
35 degrees.
So first the bearing has to have what, a north or
North.
south, right? So what is
Oh
it?
yeah, sorry. North,
Okay,
35 degrees.
right. And this is, a lot of times, students on exams forget to give me the north, south, or east, west. They just give me the numbers. Because you're working with numbers and you forget to put that in, but remember that a bearing has to have that. So how come the true bearing is 35 degrees?
Because the magnetic bearing is off by 5 degrees.
Okay, so what you're doing, what I hear you saying, is that you're looking at the angle between AB and true north because you were finding true bearing. And the angle between AB, the property line, and the true north is 35 degrees. Okay, Matt, how about the magnetic bearing?
The 30, or north, 30 degrees east.
Right. So the magnetic bearing is measured from the magnetic north, and the true bearing is measured from the,
True north.
what did I just say?
Wait,
The true
what?
bearing is measured from true north, and the magnetic bearing is measured from, Magnetic north. okay, so let's say we have, how about we have another line right here? And that's AC. Okay, going from A to C, and let's say it's 20 degrees. Oh, I told you I'd use a protractor, and I'm not happy.
These are things in the big.
Simple speech, I'm not
So Cody K, we're up to you. So what's the true bearing of this? Whoops.
Is it, one, south, 170 east?
No.
Okay,
Oh,
south.
sorry.
Southeast,
south,
correct. But remember, the bearing always has to be less than 90
Oh, yeah,
degrees,
south,
right?
70?
It's the angle from, from south to the east.
Um,
And I'm looking at this line.
15. Right?
oh, okay, 15.
Would
South,
be?
15 degrees east.
Well, we're talking about the true bearing, right? So it's the angle between the line in question and
Oh,
the true
yeah.
south, which is 20
Okay, I
degrees,
get it.
Oh, okay.
That's different.
okay? Logan, how about the magnetic bearing?
South 15
Yeah.
degrees east.
Try again. Here's the line, and here's the magnetic south,
25 degrees east.
25. Do another one?
That makes sense. Oh, my God.
Jason?
Triggering with the south.
Okay, so what angle did you try to find first? Did you try to figure out what this angle is here? Right? So what's this angle? 75. Does everybody agree that's 75 degrees?
Yep.
Because the south, true south, and the west, true west, it's gotta be 90 degrees. And if this is 10 and this is 5, this has gotta be 75. Okay, so now tell me what you said. The true bearing was? south, I can't hear you.
South 80?
Right, south 80 degrees,
West.
west. So we're looking for the true bearing, which means it's the angle between the line in question and the true. And that angle there is 80 degrees. So bearings are always measured from the north or the south, and they go either to the east or to the west. So it's coming from the south, and it's going towards the west. So it's got to be southwest, and it's 80 because the angle between the line in question and true is 80. Okay, how about the magnetic bearing, Patrick?
75 degrees southwest.
Okay, southwest, and it's 75 degrees. So one way I was even thinking about presenting it is if you take a blue sheet of cardboard, cut it in a circle, and you have your north, south, east, or actually just an axis. Take, oh, we could do, yeah, hang on. Okay, so we have, this is gonna be our true, right? So north, south, east, west, there's our true. We need a base, right?
I don't even sell those anymore.
Green must be popular. Well, actually, I can probably just do it on here, right? If the magnetic bearing, if the magnetic axis is 45 degrees off, right, now they're 45 degrees is a huge declination.
Yeah. The pole's flipped up.
Huge move.
Into the room.
Not in our lifetime, though, is it?
Every 6,000 years.
It's also not something that happens overnight.
Right.
It takes thousands of years.
Oh, it could. I'm just.
So I
How
think
you
I
know?
prefer it actually on a,
You stick one through the middle and hold the second one behind it.
That's true.
Look at Mr. Fancy
When does
Jim.
the next one start? It's already started.
I think it's spin it. If you put
Is
them
there
all on
a-
the same
Yeah.
wheel.
You stick one through the middle, you can put a second one right behind it.
Boom, and then
Oh,
you could spin
yeah.
them around. What? You could have a whole line of them.
how to
look at that.
It's fancy.
Okay,
Yeah.
so right now there is zero declination, right? And then now we have, what is it?
5.
Exactly.
About
Yeah.
15 degrees to the west, is
Yep,
that right?
that's not
What
right.
is it? It's to the east,
East.
it's your side, not mine. So it's, the declination is 15 degrees to the east, right? Now that is, this is so cool. That's about 10, it looks like maybe 11. 11 degrees to the west. And then here we have this funky angle somewhere. I mean, funky line. Here, that's probably not, doesn't stand out. There's this funky line, and if you're measuring it from, if it's a true bearing, you're measuring it to the orange. But if it's a magnetic bearing, you're measuring it to the blue.
You should
Okay?
put that on another wheel in the middle of them. And they could spin it to wherever you wanted.
Patrick?
Is there a place where we can get a magnetic declination?
Yeah, yes, we're gonna talk about that. Yeah. Okay, so I'm gonna talk about all of that kind of stuff. Let's do another problem. So I'm gonna give you a problem now, so you have a bunch of these blank things. And I'm gonna erase all this. And actually, so let's do a problem first and then we'll talk about it. Okay, so. So this problem 1. So the declination is equal to 6 degrees to the east. And the true bearing is north 62 degrees, 25 minutes to the west. And I want you to find the magnetic bearing. My first step is always I draw my line and I label everything as true. And then I draw my axis for the magnetic, and then I do my calculations.
Wait, which way? Oh, what's the circles? No, east, okay. I already made a line for that. That's the way you do it. No.
And then, are we still working? So this is what we've done. So it's true bearing of northwest is being measured from true.
Put them on back.
I agree.
Take it back, probably.
She's gotta make sure she keeps them there for the brother.
Walls and
Oh, yeah, you got some lender sources that you can reallocate it to.
Exactly.
same on the
Shutting down the street.
daytime, the crash set vibrates. Glitter, I think it's one of the batteries.
Okay, so first thing I did is I had my true axis drawn in blue. Then I drew, knowing my declination is 6 degrees to the east from the true, I measure out 6 degrees, and I put in red my new magnetic axis. Then I was given that the true bearing is from the north towards the west, so from the north towards the west, but it was true, so I had to measure it from true north. So 62 degrees, 25 minutes was right here. So this is where my line is, the property line in question. So now my magnetic bearing, I need to figure out what the angle is between the line in question and the magnetic, which would be this plus this. So it's northwest still, and now it's 68 degrees, 25 minutes. Good? Okay, problem 2. Can I get more complicated now?
No,
Yeah.
yes.
Questions on this?
I thought that was complicated.
Okay. Well, I guess more complicated. So declination changes over time. So the angle from true north to the magnetic north in 1 year is going to be different, or can be different, from 1 year to the next. So we're going to cross over 2 time periods now. So how many axes am I going to have? If I'm crossing over 2 time periods, how many north, south, east, west axes will I have? 3, right? There's a true one that never changes. I'm going to have a magnetic axis over 1 time period, and then a magnetic axis over another time period. So in 1875,
Did you?
the declination is 3 degrees, 30 minutes to the west. And the magnetic bearing is north, 65 degrees, 35 minutes east. And present day, the declination is equal to 2 degrees, 50 minutes east. What is the magnetic, what is the true bearing? And what is the magnetic bearing now, presently?
Can you please repeat, is that?
Sure.
The magnetic bearing is north
Oh, here.
65?
North 65 degrees, 35 minutes east.
Thank you.
Sorry. And the present declination is 2 degrees, 50 minutes east. Maybe Cody, maybe put one of the lights on.
Oh.
You want this
Thanks.
board thing?
Present.
Here, I still this over for you too.
Oh, no. Oh, actually, what?
Or I still this over. If you want to write on it.
Oh, okay. If I
Oh,
can
but
run
yeah,
over.
you have this
Yeah.
circles on there.
Yeah, that's okay.
It's easier to see.
But yeah, I could redraw them on here. So,
Like a huge circle. Okay,
Cody, try one of the lights up here, maybe, there's only one up there? Brian, can you see that better now that that light is on, or still no? Not
Oh, I
really?
can see it, it's just that
The
we're north of
reflection?
65, is that way, thank you.
Oh, I see that
Yeah.
strip, yeah.
Yeah, it's the dark strip of that.
Okay, so why don't I do this? We,
Oh yeah, that works.
you don't need this. Oh,
Or you could use Elmo.
There you go, now we can see.
okay. So east true, south true, and west true.
You can grab some heads.
So Daniel, you said you have 1 more year, right, next year? And then you transfer? And Patrick, you said next year?
Yeah, like full year.
Right, okay. Did anybody else say they have 1 more year?
I think I might.
Matt? Okay. What math are you in now?
Or
Yeah.
Which math you in?
2.
I'm sorry?
Like 2.
Math 2?
Yeah.
Did you take 3 already?
I took 4 and then retook. Didn't pass, so I retook.
2, and then you're gonna take 3.
Yeah.
Okay.
See, look at that.
That's it.
Are you gonna be?
SharePoint.
Oh, I see.
Jason, what math are you in?
5C.
I think he's gonna do my
So you probably have 1 more year.
Yeah, just finishing that one.
I'm sorry?
Yeah.
And is this your first engineering class, or did you take 25 already?
I haven't taken
Okay.
So that magnetic bearing was taken in 1875?
That's correct.
Okay, just making sure.
Yes.
Oh wait, I didn't look at what way these were going. Son of a gun. Let's pretend like that one's that one.
Is this your pen?
No.
Oh, that's sustainable.
That's for the true
Kind of only interesting is that Fisher further north you get, the closer the latitudes get together. I was reading that in the book and it was really good.
Let me know.
We can talk about it.
Yeah, and I don't, typically don't talk about it, so I don't have it fresh in my mind. No, I mean, I'll, during the break, I'll look at it. No, it's a good question to figure out, but, I've always been at the same latitude doing
Right,
surveying, so
exactly.
I haven't.
I think it largely depends on longitude as
Oh,
well.
yeah.
Well, yeah,
Yeah,
because
that's right.
the closer and closer together, you are.
Sure.
Yeah, think about globe, the line, because they're at the top, they're gonna get closer and closer together. Distance between them is less and less.
Between longitude lines? Right.
Yeah, 59.
I don't know, Luke was talking about that.
Latitude, it's,
Well, those are the same, you just stay the same.
it's vertical distance.
Oh, it is,
But,
right.
but the radial distance is smaller.
Distance between us.
Need a globe. It's not.
Porter, you wanna go up and do it?
I would love to.
So tell us the process that you did.
Okay, well,
Describe yours.
following your, recommendation, I first made my axis, I'm not I first made my 1875 magnetic axe.
Take a, check it out before.
Oh, it's going the wrong way. Sorry. Magnetic bearing. Oh yeah, sorry. Oops.
Actually, you might be able to use that just
Yeah,
for
that's what I
present.
did.
Just keep the present in there.
Okay.
Use the
good
purple
idea.
for present.
Yeah. Okay. It's really good access.
Everything was flat back
What
there.
happened?
Order that line is good.
I got this, okay.
Okay, well, you know what would happen, well, it wouldn't necessarily, that wouldn't happen,
It's
but.
okay. You guys know what I mean.
Well, let me explain this anyway, that you do have, not only does declination change over time, but it also changes with local attractions. So if you're doing surveying near a laboratory that might have something going on and you don't know, you have to think, oh shoot, this might actually have a local attraction, and we'll talk about that in a little bit.
Yeah, so this is just accounting for local attraction. And then,
So how do you wanna label that?
so yeah, okay, so this is, magnetic present, I don't know,
How about E sub P or something,
okay.
right? E sub P, maybe?
Okay, now we got the other one, going the other direction. A little bit more. Okay, so that's the longest part of the problem. And then I drew in my magnetic bearing from 1875.
Well, first put in the angles, right? Put in all the declination numbers.
Okay, yeah. So this is gonna be 3 degrees, 30 seconds,
Right.
30 minutes, right, 30 minutes. And then this one is 2 minutes and 50 seconds.
2 degrees.
2 degrees, 50 minutes. Got this? Okay,
You got it.
and then, draw in the magnetic bearing. I'm just gonna use black again. And that goes, so it's north, we're talking 1875, and then it goes 65 degrees, 35 minutes east. So that would be about, around here, because, okay, so 60 degrees,
The protractor thing is behind your favorite.
yeah.
You did.
So we'll just like,
Kind of.
a little bit.
So you measure that because it was a magnetic bearing in 1875, you measured that angle from the magnetic north in 1875.
Correct.
Okay.
So this is,
Well, that's better, this magnetic, true, that's magnetic.
and so then I just did some math, and from the present magnetic bearing, there's an extra 2 degrees 50 minutes and 3 degrees 30 minutes.
Do you want to write the 250 up top too?
Sure. Just grab it.
So one thing you're realizing that when, I printed these out for you and they're taking up half a page. When you go and do your homework, you tend to do something small. You can imagine that if it's small, you could screw up, right? So make sure that you're making a pretty good size so that you could actually measure the angles.
So, what's that number? That would be 5, 6 degrees and 10 seconds. Wait, no, 20 seconds, right?
Right.
20 minutes, I mean. So there's so that added to. Oh wait, subtracted from our 1875 angle should give us the angle relative to the present magnetic north. So 65,
59.
59.
All right, now.
59 degrees, 15 minutes.
69.
That's what I got.
59:15?
And it would be north
Good.
again.
And one suggestion I have here is I would, rather than putting the magnetic, everybody take a look up here, rather than putting this angle here, because we don't know whether it's magnetic or not, I would draw it in here and say, this is 65 degrees, 35 minutes. Right, because then you know it's from here to here, and then you know to subtract that to get that guy.
So then this one here.
Great. Okay, good. So, then, and that is the, so that would be, what is that the answer of?
That would be the magnetic bearing presently. So then to get the true bearing, you just add the 2 degrees.
All right, so why don't you just put the answers right next to what the questions are? So magnetic bearing presently would be north 59,
Over here.
okay, north 59, 15 east, right? And then for the true bearing,
That would be 61.
62 degrees, 5 minutes.
Okay.
Just subtract the 330.
62 degrees, how many minutes?
5 minutes. The northeast.
Northeast.
great. Okay, so, Z.
I have a question. I'll help you.
Okay. So declination then is a function of where you're located, your location, because the declination in the north of Santa Cruz County is different than the declination of the south of Santa Cruz County. So let me give you an example. So the declination, this was a few years ago. So the declination in Wydell Creek, which is near Ana Nueva. So it's north Santa Cruz County, was 15 degrees east. Wydell. What did I say?
Yes, it is.
Okay.
Yeah.
Is it two Ds or one?